Okay, good afternoon. So today we're looking at the cosine rule. For the cosine rule, we apply the cosine when we are given the length of three sides. Okay, all three sides of the angle, all three sides of the triangle is given, or we are given two lengths and an included angle. Same as we got with the application for the area rule. So for the area rule and the cos rule, we need two sides and included angle. Or if we are given three sides and we need to calculate an angle. The cosine rule says in any right angle triangle that a squared, lowercase a squared, is equal to b squared plus c squared minus 2bc cos of angle A. However, if we want to calculate lowercase b, it's going to be b squared is equal to a squared plus c squared minus 2ac cos of angle B. So if you want to calculate c, we must know the angle c. Okay, so we know that c squared is equal to a squared plus b squared minus 2ab cos of this angle c. And it's true for that obtuse triangle as well. Okay, note that a right angle side, each of the above formula use two of the sides and angle included in any given side. Okay, so that is basically what they're reminding you with regards to the proof of the sine rule. Okay, so we the cos rule. The cos rule is not examinable, so they won't ask you to prove this theorem. However, if you want to know how they derive the cos rule, I have a video out on this proof of the cos rule, area rule and sine rule as well. You can just let me know, I can direct you to that video. I'll give you the link for that video. Otherwise you can go follow these steps here. You will come out to the proof of the cos rule as well. Okay, we will be able to prove the cos rule. So now we're going to look at a couple of examples dealing with the first type, two lengths, and an included angle. Okay. So now we're looking at example 1, and example 1 is on page 348. Example 1 on page 348. Just give you a reference here, page. Okay. The question says solve the following triangle. Right answer correct to one decimal place if necessary. Okay. So to solve the triangle, we must calculate all the unknown angles and all the unknown sides. Okay, all the unknown angles and all the unknown sides. So if you consider what we have here, okay, let's make it a bit smaller. Okay, I know what I'm doing there. Okay, so as you can see, what do we have? We have two lengths and an included angle. So you've got two lengths and included angle. So I said earlier on, you're going to work out, if you're given two lengths and included angle, you're going to use the cos rule. So according to this here, this triangle ABC, I'm going to calculate A. Remember, when you're going to calculate A, we must know that angle there, which we do know in this case. Okay, so we're going to say, let me just move this up a bit. So we're going to say a squared equals b squared. So it's a squared equals b squared plus c squared minus 2bc cos of angle A. Okay, that's the order. That's the formula. Alright. So it's going to be b squared plus c squared minus 2bc cos of angle A. Okay. So b squared is going to be 6 squared plus 14 squared minus 2 times 6 times 14 cos of angle of A, which is 42. So a squared works out to be, let's punch this in the calculator, 6 squared plus 14 squared minus 2 times 6 times 14 cos of 42. It's 107,15. That is a squared, but we must take the square root thereof. So that a squared, the length of a work out to be 10,35, which is 10,4. Okay, that is 10,4 centimeters. Okay, so I'm going to put here 10.4 centimeters. So what still needs to be calculated here? We still need to calculate C, and we must still calculate B. Now if we look at what we have, okay, we have three lengths and we got an angle. So instead of using the cos rule to work out that angle there, so we have three lengths, however we got an angle, it's going to be easier for us to use the sine rule. Okay, so we can say sine of angle A over A is equal to sine of angle B over B. Oops. Equals sine C over C. Remember, between the two, the application of the sine rule is the easier one to use. Okay. So if you wanted to use the cos, you can use the cos. Okay, there's no problem with that. So what do we have? Sine angle A is 42 over 10.4 equals sine of angle B, which we don't have, over lowercase b, which is 6, equals sine of C, which we don't have, over lowercase c, which is 14. Okay, so we're going to use, that's the known ratio there, sine 42 over 10.4, that's definite. However, the unknown is at your b, so I'm going to use those two ratios. Okay, so what I'm going to do is I'm going to take that 6 up, so it's simply sine of angle B is equal to 6 sine 42 degrees over 10.6 or 10.4. Okay, so you'll put that in the calculator. 6 sine 42 over 10.4. That is 0,386. So angle beta is equal to arc sine of 0,386. Of course, the number carries on. So angle beta works out to be arc sine of that answer. So give you 22,71 or 22,7. Okay. So the only thing we still need to solve in this case, so there I got B to be 22.7. So the only thing that needs to still be solved is angle C. Okay. So how are you going to calculate C? We're going to work out the sum of triangles. So angle C is going to be equal to 180 minus 22,7 minus 42 degrees. Okay. So they plug that in the calculator. So it's 180 minus 22.7, which is the last answer calculated, minus 42 gives us 11, 5,3. 115,3 degrees. Okay. Okay, at any time you can pause the video and try and do the sum on your own first and come back again and replay it. So you don't have to watch it continuously as well, or play it in the background while you're busy with something else. So yeah, use it as needed. Okay. So in example 2 is on page 349. We are told Solve the following triangle. Write the answer correct to one decimal place if necessary. Again, to solve the triangle, we must calculate all the unknown angles and all the unknown sides. Okay. So if you see at what do we have? We have two lengths and included angle. So we can't use sine here. We'll have to use cos. So according to the cos rule here, let's pick up this. Yeah. So for the cos rule is going to be E squared is equal to, so E squared is equal to D squared plus F squared minus 2DF cos of angle E. Okay, so it's D squared plus F squared minus 2DF cos of angle E. Okay, so for E squared, so D squared is going to be 65 squared plus 42 squared minus 2 times 65 times 42 cos of angle 125. Okay, so let's put that in a calculator. So 65 squared plus 42 squared minus 2 times 65, 2 times 65 times 42 cos of 125. Okay, so E squared is equal to 9120,23. However, I want E and not E squared. Okay, so we take the square root thereof. The square root gives us 95.5. 95.5 centimeters. Okay. Now, since we got that to be 95.5, so as you can see here, I got two lengths and a non-included angle, so that you can apply your cos rule, your sine rule. Okay. So now we're going to say that sine of angle D over D is equal to sine of F over F is equal to sine E over E. So we're going to go sine of D over angle D over 65 is equal to sine of E, which is 125 over 95.5. To solve for sine of D, or to isolate sine of angle D, I take 65 up, so it's 65 sine 125 over 95.5. Okay, let's check here. So let's plug it in a calculator. So that is going to be 65 squared. No, how am I going squared? 65 sine 125 over 95.5, which comes from the previous question. Okay, not the previous question, previous calculation. So that gives us a ratio of 0,5575, and the number carries on. So angle D is going to be arc sine of 5575. And that number carries on, of course. Okay. Okay, sorry about that. So I had to take that call. So we go arc sine of that answer that we've calculated gives us an angle D of 33,9. Okay. So remember, now we got that 33.9 angle there. So to calculate angle F, the sum of triangles. Okay. So angle F is equal to 180 minus 33,9 minus 125. Okay. So that would simply give us 180 minus 125 minus 85. Last answer calculated gives us 21 comma 1 degrees. Okay. Again, if you feel confident enough, you can start doing the calculations on your own or ahead of me, and then you can just play the video and see again, okay, am I on the right track, or have I made a mistake, or things like that. Okay, I'm then now going to look at the next part. Just plug this in here. Okay, so now we're looking at, we did now example 2. If you're given 3 sides, so if you're given 3 sides, you can manipulate the formula, which is a squared equals b squared plus c squared minus 2bc cos of a. If you want to calculate angle A, it's one of two things. You're either going to memorize this formula here, or we plug in the values and then we use the formula as given on the formula sheet as well. Okay, so I'm just going to cut question 1 quickly, and then I will explain to you this question. Okay, and this is on page 350. Okay, so this is example 1 on page 350. The question says, solve the following triangles. Give your answer correct to 2 decimal places where necessary. So we told in triangle ABC, AB is 5, BC is 8, and AC is 9. Okay, so normally what I do is I calculate the biggest angle. Okay, so if the ratio comes to be negative, okay, if the ratio becomes negative, we know it's an obtuse triangle. Okay, hopefully we will have an example like that. Okay, so that your ambiguous case will be eliminated because you are already taking that into account at this point. So I always calculate the longest length, okay, and the largest angle. So the largest length here is b, so I say then b squared is equal to a squared plus c squared minus 2ac cos of angle b. Remember, if that is your subject of the formula, that's the angle in relation we must work with. Okay, so b squared is going to be 9 squared equals a squared, which is 8 squared plus 5 squared minus 2 times 8 times 5 cos of angle b. Alright, so now the idea is to isolate cos of b. So we take the 8 over, so you say cos of angle b. We're taking the 8 over, so it's 9 squared minus 8 squared minus 5 squared. Once that is taken over, we're left with this here. Negative 2 times 5 times 8 cos of b. Then we divide both sides by that factor. Okay, so we divide both sides by negative 2 times 5 times 8. Okay, so angle b is equal to arc cos of this answer we're going to get here. Okay, so you put on a calculator. But if you are a person that can memorize things easily, then by all means memorize the formula. Okay, but I never memorize the formula, I just manipulate the formula. Okay, so that gives us 1 over 10 arc sine of that, oh sorry, arc cos. So is this an obtuse angle? No, the angle is not negative. So arc cos of, that's going to give us 84.26. So angle B is equal to 84.26 degrees. Okay, so it's 84.3. Okay, so we can fill that in on our diagram. So angle B is 84.3. So remember, the question says solve the triangle. So I must still calculate the other unknown angle. So as we indicated before, sine is going to be the easier one to work with. So we say sine of angle A over A is equal to sine of angle B over B is equal to sine of angle C over C. So we say sine of A is unknown over 8 equals sine of B, which is 84,3, which we calculated now, over 9 is equal to sine C over lowercase c, which is 5. Okay. So what I'm going to do is I'm going to work with that there, as you can see. Okay. So what I'm going to do is I'm going to take 8 up. So I'm going to have sine of A. So I say sine of A is equal to 8 sine 84.3 over 9. So angle A is equal to arc sine. Remember, I've eliminated the oblivious example here, or scenario, because I'm using the largest side or largest angle. Okay. Otherwise, if I haven't used the largest side there, then it could be I must then eliminate on this basis, on the sine basis, if it's oblivious or not. Okay. So let's go. We go 8 fraction. We got 8 sine. The last angle calculated was 84,3. So yes, we go 8 sine answer over 9. So that's 0,889, and the number of course carries on. So angle A works out to be arc sine of that answer. Arc sine. It's going to give you 62,2. Okay. So now we have angle A to be 62,2. We have B, so we must just calculate angle C. So are you going to calculate angle C? Of course, sum of triangles. Okay. Let's go with the blue. So angle C is equal to 180 minus 62.2 minus 84,3. Okay. So that is 180 minus that last answer calculated minus 84.2 or 84,3 degrees. So that is 33,5. 3,5. Okay. Okay, I'm not sure if if this part of the video came out, so I'm now swapping between screens as well. Okay, so if I didn't, I was going to what's his name, just quickly just re-explain a couple of things here. Okay, so just have a look here quickly. I'm going to use yellow. So the question says we have a diagram here. We are given 3 sides. Okay, so remember 3 sides, we must use the sine, the cos rule. So I said that if you got 3 sides, what I do is I always take the largest side. Okay, so to eliminate if it's obtuse or acute angle. So we say b squared is equal to ac squared plus c squared minus 2 ac cos of angle b. Okay, so that's the angle I was going to work out. So what I do is I then take 8 over the equal sign, take 5 over, so it becomes 9 squared minus 8 squared minus 5 squared. Then I'm left with this here. Okay, so what I do is I then divide both sides by negative 2 times 5 times 8. So it's got cos of b on its own, as you can see there. I worked it out, that gave me 1 over 10. Or cos of 1 over 10 gives me 84,3. Alright. Then I established, okay, the sine rule is much easier to work with than the cos rule. So what I do is I say sine A over A is equal to sine B over B, which is equal to sine C over C. Now we say, okay, you got sine of A, which is unknown, over 8 is equal to sine of B, which is 84,3 over 9 is equal to sine of C, which is unknown, over 5. So I establish, okay, we're going to work with this here because there's one unknown. I could have worked with this here as well, this part here. Okay, if I wanted, I would have then calculated angle C. Okay, but I went with this here and I calculated A. I took 8 up, so sine of A is equal to 8 sine 84,3 over 9. Angle A then works out to be 62.2. Then to calculate C, it's going to be simply sum of triangles there. Okay. Okay, for this question here, we are told that in triangle LMN, LM is given as 5, LN is 3, and lowercase l or mn is 7. The question says solve the triangle. So to solve the triangle, I must work out all the unknown angles. Okay, as you can see, all the sides are given. Alright, so as I said, indicated before, if we use the biggest angle, we will be able to see if it's obtuse or not. So we'll start there. Okay, so it's going to be L squared is equal to, so you say L squared is equal to N squared plus M squared minus 2mn cos of angle L. Okay, so I'm going to work out angle L first. So lowercase l is 7, so 7 squared is equal to 5 squared plus 3 squared minus 2 times 5 times 3 cos of angle L. Okay, so for cos of angle L, I'm going to say 7 squared minus 5 squared minus 3 squared. So I'm left with this only, so I divide by negative 2 times 5 times 3. Okay, as I indicated in the previous question, if you are a person who memorize really well, we have no problem with you calculating it using the manipulated formula you remembered, as long as you're using the formula properly. Okay, so let's work this out here. I hope this is going to be a negative angle so that you can see what I was talking about. So we got the 7 squared minus 5 squared minus 3 squared, and that is over negative 2 times 5 times 3. Okay, that gives us negative, there we go, negative half. So we just change our color here, so that gives us an angle of negative half, a ratio of negative half. So when I say, okay, now this is going to be an obtuse angle, so let's call this a reference. R cos of half. Now I know some people use the negative angle. It will give you negative 60, and then it's going to then of course give you in the second quadrant is 180 minus 60, okay, which is 120. So that will simply give us 60 degrees if I use the negative angle, so, positive angle, sorry. So it's either in first quadrant or second quadrant. Remember, it's negative, so it has to be the second quadrant because cos is negative in the second quadrant. So therefore L is an obtuse angle, so it's going to be 180 minus 60, which is 120 degrees. Okay, so L is 120. Okay, now since we have taken that into account here, we've taken the biggest length, so the oblivious case of the sine rule is not going to be applicable here. Okay, so yes, it is an obtuse triangle. Okay, so now to calculate what is that m, so I'm going to say sine m over m is equal to sine n, sine n over n is equal to sine L over L. Okay, so you got sine m, it's unknown, over m, which is 3, equals sine of n, which is unknown, over 5 equals sine of L, which is 120 over 7. So I'm going to work with that there. Take 5 up. Let's say therefore sine of angle n is equal to 5 sine 120 over 7. So we've got arc sine of the ratio I'm going to get here now. Let's just work this out. That's going to be 5 sine 120 over 7. So that's going to give us 0,6, and the number of course carries on. Okay, let me just see if you guys can see this. Okay, it's behind the calculator. Okay, so I'll move it over a bit. Okay, so arc sine of 0,62. So arc sine of that answer. Remember, use this answer button. So it's going to give you an angle of 38,2. 38,2 degrees. So remember, now I've got this angle here also. So to calculate angle M is going to be sum of triangles. Okay. You can go again with sine rule, but so much unnecessary calculations there. So M is going to be 180 minus 120 minus 38.2. Okay. Just see here, so 120 now. Right. So we got 180 minus 120 minus that answer that was calculated in the previous question. I'm going to give you 21,786. It's 21,8 degrees. Okay. Okay, now we're looking at exercise 10.5 on page 352. We are told that use the cosine rule, which is the cos rule, in its various forms to complete the following triangle. So here we got triangle. So it will be triangle PQR. Okay. So angle P, remember lowercase p is there, lowercase r is there, lowercase q is there. So P squared is equal to r squared plus q squared minus 2rp or pr cos of angle P. Okay. Let's look at the number 3. I'm going to come back to that one now. Number 3 is going to be r squared is equal to p squared plus q squared, as you can see the space is little, minus 2pq cos of angle r. Okay. Number 2, they want you to work out q, angle q. Alright, so this will be q squared minus r squared minus p squared over negative 2r times p equals cos of angle q. Otherwise you could have said, okay, since they wanted to work out angle q, I can firstly say that q squared is equal to r squared plus p squared minus 2rp cos of angle q. Okay, and then you make q the subject of the formula by saying q squared, you take it over minus r squared minus p squared. Since I'm left with that only, I divide both sides by negative 2rp, which is simply cos q is equal to that. Okay. Then for number 2, in number 2 we are told in each case solve the triangle working correct to one decimal place. Okay, so again we got triangle ABC. Okay, we got AC to be 9, we got AB to be 5, and you got angle A to be 65. As you can see, We have two lengths and an included angle. So that I can calculate lowercase a at this point. So a squared is equal to this lowercase b squared plus c squared minus 2bc cos of angle a. So it's going to be 5 squared plus 9 squared minus 2 times 5 times 9 cos of angle 65. Okay. Okay. So you can punch that into the calculator. Gives us 5 squared plus 9 squared minus 2 times 5 times 9 cos of 65 degrees. So a squared is equal to 67,96. The square root thereof is going to be 8,2. So a is 8,2 centimeters. Okay. So as I indicated before, it's going to be easier to work with the sine rule. Okay, so I can just say simply sine of c over c is equal to sine of b over b is equal to sine of a over a. So it's going to be sine of c, which is unknown, over the c. So opposite c you've got 5. Is equal to sine of b over 9 is equal to sine of a, which is 65 over 8.2. So that I can be able to calculate angle B at this point. Okay, let's change my color here. And calculate angle B here. I take a line up, becomes sine of angle B is equal to 9 sine 65 over 8.2. Okay, so to get angle B on its own, I'm going to say arc sine of, in the calculator it's going to be 9 sine 65 over 8.2, which will also answer calculated 0, 9, 8, and number of course carries on. So arc sine thereof will give me a beta angle, where angle B, 81,6. So 81,7. Okay. So now I have B. You just fill this in, populate the diagram. So 81.7. Now to calculate C, sum of triangles. Okay. Angles in a triangle adds up to 180. So it will simply be, let's use that one, let's see. So angle C is equal to, a little bit thicker. So angle C is equal to 180 minus 81,7 minus 65 degrees. That's your sum of triangles there. So it's 180 minus the answer minus 65 gives us 33,3 degrees. Okay, sure, this is getting a bit easier now. The more you do, the better you'll become at it. Okay. Okay, so in question 3D on page 352, okay, we are told that in triangle GHI, so let's draw the triangle GHI, HG is 7, HI is 9, GI is 4. So as indicated before, if we need to solve the triangle, in each case solve the triangle as we were told, we need to calculate all the unknown angles and all the unknown sides. In this case we've got all the sides, so we're going to go with all the unknown angles. Okay, so let's go with that. So we're going to always go with the largest length. So if it's obtuse, we'll pick it up immediately. So we can say then in this lowercase g, so g squared is equal to I squared, I squared plus h squared minus 2i cos of angle g. Okay, so we're going to work this angle out. Of course, it's going to be 9 squared is equal to I, which is 7 squared, plus 4 squared minus 2, 7 times 4 cos of angle g. So it becomes now 9 squared minus 7 squared minus 4 squared. Must be divided by that part there, which is negative 2 times 7 times 4 equals cos of angle g. So angle g is going to be r cos of whatever that ratio is going there. Okay, so let's put that in the calculator. Your handwriting settings is worse than worse. So you got 9 squared minus 7 squared minus 4 squared over negative 2 times 7 times 4. That gives us negative 7 over 2. Okay, so this gives us, I put it in a different color, then there, negative 2 over 7. So I take r cos, I take the positive part thereof. Okay, and we say, okay, since cos is negative, it has to be the obtuse angle. Okay, so it's negative in first and second. We won't get a triangle that has an angle in the fourth quadrant. Okay, so you say r cos of negative of 2 over 7. So r cos of 2 over 7 is 73, 4. 73, 4. So that is my reference angle of G is 73.4 degrees, and now my angle G is going to be 180 minus 73.4, which makes that your obtuse angle. So it's 180 minus this angle here. Give me the answer, 106.6 degrees. 106.6 degrees. Okay, let's write it in there, 106.6. So in pursuit of calculating h, I'm going to go with the sine rule. Okay, well, I'll write it here now. So let's go, we'll say, let's change the color. So it will be sine h over h is equal to sine g over g is equal to sine I over I. Okay, so sine h, it's unknown, over h, which is 4, equals sine of 106.6 over 9. Okay, which is equal to sine of I over 7. We take it up. So there we go. So it will be sine of h equals 4 sine 106.6 over 9. Okay, so angle h is going to be arc sine of, and I can work this out here. So it's going to be 4 sine 106.6 close the brackets over 9. Okay, so that's going to give you 0, 4, and the number carries on. 2, of course, and the number carries on. The arc sine of that, shift sine, that answer gives us 25,2 degrees. So h is 25,2 degrees. Okay, which is this. So in pursuit of calculating I can go with sum of triangles. So angle I is equal to 180 minus 25,2 minus 106.6. Okay, let's move this up. So it's 180 minus the previous answer calculated minus 106.6. Okay, so that makes that angle I equals 48,2 degrees. Okay, I think I've done enough of this now. You guys can just conclude the exercise 10.5, and again, if you have any problems, please let me know. At this point you will pause your video and then you'll do that exercise, but I will follow this up now with the last part, which is the combinations of your triangles. Okay. Okay, so now we're looking at the example on page 354. Okay, the question says calculate the area of this quadrilateral ABCD. So you want to calculate the area of this quadrilateral. There's no formula where we can calculate this in one go. Okay, we have to break it up in basic shapes here, two triangles. So it's going to be the area total. It's going to be the area of triangle ADB plus the area of triangle BDC. Okay, so now the area of a triangle for this triangle here, as you can see, there's 90 degrees. Okay, so it's going to be half base, which is AB, times perpendicular height, which is, so that's your base and that's your perpendicular height, or that's your base and that's your perpendicular height. Okay, so it's AB times AD. Okay, plus, now the area of this triangle, I need two lengths and included angle. Since I got that angle there, I need to calculate that length. Okay, so there's the two lengths and included angle. Okay, so in other words, it's going to be half BC times DB sine of angle DBC. Okay, so if you look at what we have, okay, let's just tick what we have. The half is in the issue, is going to be, we need AB. Okay, as you can see, it's unmarked there. We have AD, we need B, we got BC, we need DB. So we need that length as well. Okay, so to calculate those lengths, okay, I'm going to use either the sine rule or cos rule, or we're going to use the basic trigonometric ratios which we were dealt with from grade 10. Okay, sine, cos and tan. Remember, sine, cos and tan can only be used in right angle triangles. Okay, so if you're looking at calculating AB first, okay, so it's in triangle, you don't have to write this, but since there's more than one triangle, I tend to write this in triangle ABD in this triangle. You see here, we want to calculate reference to the angle, it's your opposite, and my adjacent, so that is tan. Okay, so we say tan of 38 degrees equals opposite, which is AB, over adjacent, which is 6. Cross multiply. So AB is equal to 6 tan 38 degrees. Okay, so we go 6 tan 38. So that gives you 4,7 centimeters. Okay, so now I got that as well. Okay, See what else I need to calculate. So I need to calculate BD. Just change the color here. So we now say in triangle BDC. Oh, my handwriting. BDC, which is this triangle here. Okay. So what do we have? We have this length here as well now, which is 4,7. So I can apply Pythagoras and get this length. Yeah. Why Pythagoras? So it's a right angle triangle. Okay. Or I could have said, this is your adjacent and hypotenuse. I can use the cos rule, cos of which is adjacent of hypotenuse. Then either one would get you the right answer then. So I'm going to go with the cos rule and Pythagoras. So it's going to be BD squared is equal to 4,7 squared plus 6 squared. Okay. So that is going to simply give us BD. So you put in a calculator, that answer squared plus 6 squared. It gives an answer 59,97. But remember, they want BD and not BD squared. So they give you 7,6. So it's 7,6 centimeters. Okay, that is 7,6 here. So remember, what did they ask you? They wanted the area of the quad, the four-sided figure. So it's going to be half AB, which is 4.7, times AD, which is 6, half base times height plus a half, BC, which is 5, times 7.6 sine of 69. Okay, so let's see what we get here. It will be half, it's 0.5 times 4.7 times 6 plus half times 5 times 7.6 times sine of 69. Okay, that gives us 33.8 centimeters squared. So that's the area of the figure. Okay, so I'm not going to do another one. I'm just going to lead you through the sums. So I'll give you a chance to do it. I also don't want you to stuck. Okay, so let's have a look here quickly. So that's the example we just did now. So you guys are going to stop the video, of course, and do exercise 10.6. So in 10.6 the question says determine the area of each of the following polygons. The polygons is basically an enclosed figure made up of with n amount of sides there. You may use to add, you may need to add, not use to add, you may need to add construction lines to form triangles here. So of course we're going to construct here AC in the first one. So you can have this triangle here and that triangle there. We have dealt with something like that before in number 2, a parallelogram. So you draw that line there. There's a kite. So we'll of course draw that line down here. No. Why? Because there's your included angle. So you've got two lengths in included angle. So you work the area of triangle K, EI and then EIT. And then you add those two together. Here we divide here EO. We will have a triangle and a square there. Okay, there's a nice question, question 5. And then question 6 is your trapezoid, your trapezium. And you already have, okay, so this question as well, it leads you through what you need to do in order to calculate the area of the trapezoid or the trapezium as well. Okay, as I said, this is enough information now for you to do exercise 10.6. okay, if you have any problems, please let me know, and I'll try and sort it out for you. Okay, enjoy the rest of your day.